Good morning, everyone. I hope you're having a great day today, and I'm happy to be here. This is Coach Johnson, just giving you, our short little version of today's lesson. Now, today we're going to be talking about, again, we started chapter 2, the earth, yesterday, and today we're going to be talking about the next section in chapter 2, which is about like the geology of the earth. Okay. Now, just a little bit of, like building up a geography literacy here. In 1906, San Francisco was a huge booming city, starting to become one of the largest cities in the country, but it was destroyed by an earthquake that measured 8.6 on the Richter scale. So just to put that in perspective, that's massive. Like most earthquakes don't even, approach like a 3. You don't even feel them. This one, destroyed 28,000 buildings, killed over 4,800 people, and just completely leveled the city. Now, in 1989, there was a less forceful earthquake that also struck the city. Got to remember, California, it lies on fault lines and along, essentially plate boundaries, which we'll discuss more in a minute. But the thing about this, like San Francisco, is that it's been hit by a few earthquakes. And now this one in 1989 was less damaging, but it still killed 67 people, which is not an insignificant number. Now, most people actually remember it, though, because it interrupted the World Series for 12 days because the two teams that were playing were the Oakland A's and the San Francisco Giants, which, if you know anything about those like sports, that those two cities are right next to each other. So it basically halted the World Series because the two teams literally could not play each other because they were both located in the San Francisco area. Just, fun fact. Now, to kind of get into the topic here, the Earth is made up of 3 layers. This is something that should be probably refreshers for you from elementary school or middle school. You have the core, the mantle, and the crust. Now, the core is actually developed of 2 pieces. You have the inner core, which is about 4,000 miles below the Earth's surface. That's really deep. It's also extremely pressurized. And, for what we know is that the inner core is actually made of metal. Like it's solid metal. And then the outer core is about 1,400 miles thick. So not only is the inner core smaller, but the outer core is thicker, but it's made of moving metal. Okay. And then both are made of iron and nickel. Then you have the mantle, which is made of hot, dense rock. The core is actually cooler than the mantle, from what we know. Granted, nobody's ever been there, so there's no real way of knowing for sure. But the mantle is made of hot, dense rock, which occasionally will spill out onto the Earth's surface. We'll talk more about that in a second. But this mantle releases 80% of the heat generated from the Earth's interior. So a lot of the heat that warms the Earth is actually coming from our mantle, which is that second layer, which you can see here. Like you have the crust, you have the mantle, you have the outer core, and then you have the inner core. So just to kind of give you an idea of how these work. The crust is actually not very thick. It's only about 30-ish odd miles thick, which seems like a lot, when you think about 30 miles as the distance from here to the other side of Shreveport. But that being said, that's not really that thick when you consider that the other ones are, hundreds of miles thick or thousands of miles thick. Now, as I was saying, the outer crust is a layer of rock that varies in thickness. It has, from 2 miles, that would be around the Marianas Trench, to 75 miles, which would say be the Himalaya Mountains. And it's broken into a dozen or more great slabs that we call plates. These are different pieces that are like constantly pushing and pulling on each other, and they rest on a layer of the upper mantle. And these plates are what actually hold our continents and oceans together, and it's also what causes fault lines, volcanoes, earthquakes, all these different, things that help shape the Earth. And this is because, this is caused scientists, discovering these plates, to have this, theory about continental drift. Now, remember, a scientific theory is something that has been tested and proven, but they don't want to call it a law because it's constantly up for reevaluation. But they believe that all the continents were once joined together, the great supercontinent Pangaea, and that they have all broken apart and drifted, and this is called continental drift. And eventually they'll all meet back again at a different spot. These plates move gradually. I mean, we're only talking like a couple centimeters to inches a year, not very much. But as they move, they come together and pull apart. So it takes thousands of years for any significant movement to happen. This movement also pushes up mountains, creates volcanoes, produces earthquakes. So a lot of the stuff that we associate with the land is part of this plate movement. And the official term for this is actually called plate tectonics. That's the science of plate movement, of continental drift. Now, this is just kind of a, picture of the different types of areas that you'd find in one of these plates. So you've got, if you see some of the plates that have, these outer bound, like where it's pushing out, that means that's where it's coming out and the land's being pushed. And then you got these other ones here pushing. Okay, actually, these are volcanoes. I'm sorry. Then you've got, anytime where you see the arrow, that's where the boundaries are pushing out. So this is where you had the seafloor spreading, usually along a ridge or a trench. Even though the trenches are also where they subduct, this means is where it goes under. So where you see volcanoes is where a plate is going under, and where you see the arrows, that's where a plate is spreading from. So it's kind of like moving, almost like the wheels of a tank. You know how they're constantly moving in one direction and like it's rolling around. You kind of get an idea there. Now, one way that mountain ranges form is in a process called subduction. So that's when plates collide and one goes under and it pushes the other one up. So like the Himalaya Mountains were actually formed, if we go back here, when the Indian subcontinent hit and started pushing up the Himalaya Mountains. They're relatively newer mountain range. Continents also grow in a process called accretion, which is when the pieces of the Earth's crust come together slowly as a sea plate slides under a continental plate. So when the sea plate slides under, the continent gets bigger. And when two sea plates collide, they also may create a chain of islands. So, some of these chains of islands that you'd find in the Pacific are where like plates are colliding, especially along what's known as the Ring of Fire. So this is just an example of, say, the Cocos Plate and the Caribbean Plate, where you have the subduction zone start and the volcano forms to help create this new land. And then you can see here the accretion method, which is where over time, as the continent expands, it actually will build up. Now, when the plates squeeze the Earth's surface, they also create folds or bends in the layers of rock. And when they slide past each other, these are known as faults. So, folds will look kind of like waves in the rock. Or, not like breaks, but it just looks like waves. Whereas a fault looks like a break. Probably the most famous in the world is the San Andreas Fault, which is where a lot of earthquakes, especially the ones that affect California, originate from. And of course, this leads to earthquakes, which are sudden violent movements along the fault lines. And these, can cause a lot of damage, and they will create these massive shifts in the earth. And that's really all an earthquake is a sudden shift in the earth. The Ring of Fire is actually a zone of earthquake and volcanic activity that surrounds the Pacific Ocean. And so many of the islands that are formed in the Pacific were actually part of this Ring of Fire chain, and many of them have volcanoes that are constantly erupting and creating more island. Hawaii is an example of this. Mount Kilauea is always going off and creating more island. Now, the cities in this area like San Francisco, Los Angeles, Tokyo, those cities are prone to severe earthquakes from time to time. So as you can see here, you have along the Ring of Fire, you've got this whole region that is just a series of volcanoes and plate movement. And it's constantly, contracting or expanding. Along the west side of the United States, you have, which is part of the Ring of Fire, you have more volcanoes and plate lines and fault lines. So you can see why there's a lot of activity in these areas. And in many cases, some of them have some very bad moments. Probably the most recent that you would be aware of would be when there was the tidal wave off the coast of Japan, and it destroyed the Fukushima reactor. This has happened in your lifetimes, but it was like that was because of the heavy fault line activity along Japan right here. Now, and then occasionally there are what are known as hot spots, which is where a volcano will just randomly appear because I guess the mantle needs a place to, send out. And that would be where the Hawaiian Islands have formed. So they're not really anywhere near a fault line or a trench line, but it created the islands nonetheless. And then this, of course, leads to volcanic eruptions, which is where magma is broken through the Earth's crust, becomes lava, and it helps create new mountains that are spewing out this new land, new earth, new rock. Now, they often rise along plate boundaries, but as I said, occasionally they'll have what's known as a hot spot. But they also occur which is when these hot places blast their magma to the surface. You have several different types of volcanoes. You have your fissures, which is basically like a break in the earth, like creates a lava pool. You have your shield volcanoes, which are like very gentle sloping, and they, will send out lava, just kind of nice and gentle. You have your domes, which essentially do a lot of the same thing. But the thing is that while these can be dangerous to be around if you get too close to the magma, most of the time they're usually just constantly going, and it's not really that big of a deal. The dangerous ones are actually your ash cinder composites, and your calderas are more like just kind of done. But your composites and your ash cinders are the ones that have the big explosions, and those can be very dangerous. Probably one of the most famous was Mount St. Helens in 1980. It literally, the entire mountain exploded, and it destroyed a lot of stuff, killed a lot of people. So you can kind of see some of the different types of eruptions here. So like in Iceland, that's where you'd see the fissure types, and that's, there's just kind of just a nice steady stream of lava coming out, creating new stuff. Hawaiian eruptions kind of do the same thing. And then you have other different types, Vulcanian, Strombolian, Palean, and Plinian. Palean would also be what destroyed Pompeii back in the ancient days of ancient Rome. These are the ones that explode and create a lot of havoc. But as I said, a Palean is the one where the mountain will literally blow up. There are other external forces you need to be aware of. You have physical weathering, which is when large masses of rock are broken down into smaller pieces. So basically, like over time, either through water or wind, the rocks just kind of break down from going from bigger pieces to smaller pieces, and it will actually change. Like you have chemical weathering, which will change the chemical composition of the rocks. So they'll become they'll get formed from igneous rocks to sedimentary, etc. There's wind erosion, which is taking the movement of dust, sand, and soil through the wind. That's erosion. So it's just taking this stuff and moving it to a different place. Water does the same thing. But this can be very devastating to some areas and bring mineral riches to the soil in other places. So it's taking the stuff that was there in one place and putting it in another. Like this is an area where some wind erosion and even some like water erosion has taken place. Then there's glacial erosion, which is where glaciers, which are gigantic, large bodies of ice that move very slowly across the Earth's surface, will kind of like shave it, in a manner of speaking. They carry rocks and soil, and they just kind of like, make things smoother. The Appalachian Mountains, if you've ever been to those or seen those, they don't look like your normal mountains because they're kind of smooth and, pretty, lots of trees. Whereas when we typically think of mountains, we're taking big, jagged pieces of rock. But that was formed by glaciers thousands of years ago. And then there are actually types of glaciers. You have two types. You have sheet glaciers, which are flat, broad sheets of ice. And then you have mountain glaciers, which are located in high mountain valleys. And then there's water erosion. Famous example of this is the Grand Canyon, which is because there's a river that goes through the middle of it, and it is like worn down the rock until eventually it makes a giant canyon. So it wears away the soil and rock, and this is water erosion. Again, it often forms valleys and canyons. And these are just some of the forces that, help shape the Earth as we know it, which will again help determine where we are in the world and why people live certain ways and live the way they do. Okay, I hope you enjoyed this lesson. Hopefully you got something out of it. I will talk to y'all tomorrow. See you tomorrow. Hope you have a good day and take care and stay safe.